All right, for this first question that we have here, we're given 5 sets of quantum numbers, and they're asked to decide whether those sets of quantum numbers are allowed or forbidden by the rules of quantum mechanics. If they're allowed, then you're asked to name the orbital that they describe. All right, well, what's all this talking about? Well, going through all this complex math, what they arrived at was, for a hydrogen atom, that there's certain allowed values for each of these. So n has values starting at 1 and going as integers up to infinity. Okay, integers are counting numbers, 1, 2, 3, 4, 5. Okay, and then your n value sets the next quantum number. So L has values from 0 up to n minus 1. So depending on what particular n value you have, this is going to go up to n minus 1. And so if n is equal to 4, for example, 4 minus 1 is 3. So 0, 1, 2, and 3 are allowed values if n is equal to 4. And we have this other quantum number, m sub L. It has values from whatever L was, from minus L through 0 to plus L. Again, only integer values. And so, for example, if we had an L value here of 3, we would have minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Then finally, very important but less exciting value here is what's m sub s, which can have values of plus 1/2 or minus 1/2. Only those two values are possible. Okay, so here's what we do. We go, and you'll want to start this analysis from the left side to the right side. That's the best way for this to work. So n equals 2. Well, any integer value, 2 is an integer value, so this is okay so far. I like to go across and put check marks as I check these off. And I'm always going to go one step back here. So L will have values from 0 to n minus 1. Okay, n is 2, so this for n equals 2, possible values of L are 0 and 1. So 1 is a good one. Okay, now if L is equal to 1, m sub L would be minus 1, 0, and plus 1. So 0 is most definitely a good number. And then I said m sub s can be plus 1/2 or minus 1/2, so that most definitely is good. So yes, this is a allowed electron configuration. I'll save this last column here till the end. All right, now, and let's start on the next one. So if n equals 3, yes, that's a good number. If n is equal to 3, L can go up to 3 minus 1, which is 2. So L equals 2 is also a good number. If L is equal to 2, then I go minus 2, minus 1, 0, plus 1, plus 2. So minus 1 is good. And then this can be plus or minus 1/2. So that configuration is also a good one. Okay, I'll go here, n equals 2. That's a good quantum number. If n's equal to 2, L can go up to 2 minus 1, which is 1, so that's a good number. If L is equal to 1, so if L is equal to 1, minus 1, 0, and plus 1 are good numbers. Plus 2 is not in that set. So, and if we have any break in the bridge, one break in the bridge makes the whole bridge fall in. This would actually be okay, but this one calls, if any of the boxes get an X, then the answer is no. All right, now n equals 5, good number. If n is equal to 5, L can go up to 4, so that's a good number. If L is 3, then m sub L will go from minus 3 to plus 3, so minus 2 is a good number. But now we hit a snag here, so m sub s can only have values of plus 1/2 or minus 1/2, so. All right, and then now let's go to this one. So if n is equal to 4, L can have values up to 4 minus 1 or 3, so we already have a problem here. The first one is okay, the second one's not, and then it doesn't really even make sense to go on after we find one that's not. And so if any of them are no, then it's no. All right, well, what about this name business? Well, for 3 of these, it doesn't make any difference because we don't name things that don't exist. But for the 2 that we found that are allowed states of these atoms, we should name them. The first part of the name is simply the n value, so 2 and 3. And then the second part, it gets used so often in chemistry, it gets a code. So 0, 1, 2, 3, these are L values. They get the names S, P, D, and F. So L equals 1 is called a 2p orbital, and L equals 2 is called a 3d, or is a d orbital. So the first number is the n value, the second number is the code for the L value, 2p and 3d.